So welcome to the November 5th, 2020 meeting of the Kubernetes VMware User Group. Today on the agenda, we have a presentation by Gopala on the new features related to the 7.0 Update 1 release of the vSphere hypervisor and how that might relate to running Kubernetes on top of that infrastructure. I've put a link to the agenda doc, and just in case Gopala's presentation doesn't last the full hour, we may have time to open this up to birds of a feather discussions on any topic that people might like. So I'd invite you to go ahead and add whatever you like to that agenda for open discussion. If we don't have time for it in this meeting, we'll just roll it over into the next one. So with that said, I'm going to turn it over to you, Gopala. I think I made you a co-host, so you should be able to share a screen if you've got anything to present.
Yes. Thank you, Steve. And thank you for having me today. Good to meet you all. My name is Gopala. I'm the product manager in VMware. And my main focus is cloud native storage. I own the cloud native storage parts, the roadmap in VMware. And I also focus on onboarding modern stateful services like object stores, like MongoDB, like Cassandra, Kafka, etc., on the vSphere platform, right? So that's been my focus as well. So what I'll be talking about today is I'll be presenting the deck that we shared in VMworld, which is essentially the newer features that we are offering in vSphere 7 as well as 7.0 Update 1. Right. So the majority of the content here is mostly on the container support, the Kubernetes support in both 7 and 7 Update 1. I'll also talk about one of the new features that we offered called vSAN Data Persistence Platform, which is essentially making it easy for customers to run object stores, Kafka, Cassandra, such applications. The primary reason is the Kubernetes applications that we see customers running frequently depend on these types of services, right? So I want to talk about how we are making it easy for customers and developers to get that access on vSphere. So I also have Miles with me, who's in my team. So so please feel free to ask us any questions. Stop me anytime. We'll be happy to take your questions. All right, so before we talk about what we have done in vSphere 7 and 7 Update 1 for Kubernetes and containers, a very quick refresher on why VMware is embarking on this journey. We clearly see that the industry is changing when it comes to applications. We are seeing a shift from monolithic applications to microservices. These applications, the modern applications, are frequently designed as a set of many different microservices, each of which could be independently developed, independently scaled, independently lifecycle managed, and each of them could use a separate technology. So it makes it much easier for customers to write scalable, geographically distributed applications. And it turns out that containers lend themselves very well to microservices because of the nature of these containers. They are able to quickly be developed, instantiated, updated, provisioned. So containers lend themselves very well to these microservice-based applications. But what they offer is they offer a management challenge. As the number of containers increases, number of microservices increases, for a customer, it becomes problematic to manage them. So that's where Kubernetes comes in and solves that management challenge for our customers. And these Kubernetes started off with supporting stateless applications, and state used to be generally managed outside of these Kubernetes applications. But then customers realized the benefits and power of Kubernetes and wanted to also bring in Kubernetes into that mix for stateful applications. And along the way, Kubernetes has evolved and offered more and more support for stateful applications. And of late, we are seeing this evolution to even support highly distributed, complex, distributed stateful applications like distributed databases, object stores, So we'll talk about it. So we see the shift, and Kubernetes is becoming a mainstream in the enterprise. So that's the reason VMware has invested a lot of effort in supporting these applications for our customers. So cloud native storage, this is what we introduced in 6.7 update 3, which was last year, VMworld. Around September, we introduced our first version. This year, we have expanded that capability, and we are offering more enhancements to this platform. But in a nutshell, what we have is we have the CSI driver, which is the out-of-tree Kubernetes storage driver with the vSphere CSI driver. And with this, we are offering block and file-based persistent volumes. The secret sauce that cloud native storage offers is that bringing the two worlds, the vSphere world with the Kubernetes world, and we are merging the two worlds here when it comes to deployment, when it comes to operations, all of that. We are making it easy for customers, developers to write their applications on Kubernetes that runs on vSphere, right? And we bridge the two constructs here. Things like storage classes on Kubernetes are all now integrated with the storage policies on vSphere, right? Which means that developers will continue to use their existing Kubernetes knowledge and develop their applications, while vSphere administrators, operators will manage these modern application workloads using their vSphere knowledge without having to understand a lot of nuances of the newer technologies. And what this also gets us is that operational consistency, unified management between modern applications as well as traditional applications. So customers can manage both of these types of workloads on the same cluster, right? And we also have support for data protection using the Velero integration. Velero is a data protection backup orchestrator for modern applications. So it goes through the different namespaces that are deployed on the cluster, and goes through the different volumes in those namespaces and orchestrates those backup for these different volumes. And we have the integration of Velero with the CNS, right? Starting from 7.0, we have that capability. So with this, customers can use Velero to take backups of their Kubernetes clusters that are running on any of the vanilla Kubernetes distributions.
So Gopala, is it okay if we ask questions while you're going, or do you want them saved to the end?
No, please keep them coming as and when you have them.
So it's my understanding that I think that this cloud native storage switch that was in 6.7 update 3 is kind of where you enabled a scenario where the volumes had life cycles independent of VMs. Is that correct? Because that's sort of a big thing with Kubernetes, given that the mapping of a pod to a Kubernetes worker node is ephemeral, so that really that Kubernetes worker node might be a VM when you're running under running Kubernetes, but that attachment to the volume really has only a dotted line temporary relationship to that VM. So allowing separate life cycles was a pretty big deal. Do I have that right?
Oh yeah. So Stephen, thank you for bringing that up. Yes, I had another slide wherein I wanted to talk about it, but yes, it's a great point that you bring up, right? That independent volume lifecycle management is one of the key benefits of CNS. So here, the persistent volume has a complete lifecycle of its own. It is persisted on the underlying storage. And it can be attached to these worker nodes as they come in, right? And you can have these pods go away and then get attached to the persistent volumes. But yes, that is one of the key benefits of CNS that we introduced last year.
Okay, thanks for the clarification.
Sure, awesome. And this is just a slide here to talk about how the Kubernetes provisioning is integrated onto vSphere. So what we are showing here is a dynamic provisioning of read-write many persistent volume in Kubernetes, and how it translates into an actual object on the underlying storage layer, and what is involved in this operation here. So what you're seeing here is there is a CNS component. There's a CNS driver that runs within the vCenter, right? And we have SPBM, which is our policy-based management engine that is also running within vCenter, right? So this is the engine that understands policies. Now, in Kubernetes, we have the CSI provisioner for vSphere, right, which talks to CNS for all its control operations, right? Create, update, delete, lifecycle management of the persistent volume itself. So let's take an application that is interested in read write many persistent volume, right? So we have the storage classes. So let's say there is an SPBM policy on vCenter that says, hey, create this read write many persistent volume with two-way replication, and let's say there is a policy for that. And what the DevOps admin does is he creates an storage class that mimics that particular storage policy on vSphere, right? So it simply points to that storage policy, the storage class points to that. And then once you have this storage class that is now pointing to the underlying SPBM policy, you can now instantiate an application and refer to that particular storage class, right? So the storage class, when it's referred to it and when the application is actually instantiated, what happens is now the storage class is given to the CSI provisioner within Kubernetes, and CSI talks to the CNS plugin within vCenter, and CNS is now going to interpret this particular policy that is associated with this particular storage class and hands it off to the SPBM policy engine. This SPBM policy engine here now interprets the actual policy and then creates a read write many persistent volume, which is now backed by a vSAN file share on the underlying storage with two-way replication. And on the way back, it is going to then associate this particular file share. It's going to create a persistent volume and then hand it all the way back to this application. Right, so now you have an application that is now has a persistent volume claim, persistent volume attached to it that is now deployed on a vSAN with that replication. Right, so the summary is that with this SPBM policy to storage class integration, the provisioning is seamless, and with this dynamic provisioning, customers do not need to worry about having that persistent volume be created upfront. So they get that dynamic provisioning with the storage class, and administrators again just deal with policies, and developers continue to deal with the storage classes. Right, and this is the automated volume lifecycle management that we talked about in the previous slide, which is an important aspect of CNS and CSI. So, so the other feature that we released in vSphere 7, which was not there as part of vSphere 6.7 update 3, was the support for read write many persistent volumes. Right, this enables customers to share data between the different pods using the read write many persistent volumes. And as of vSphere 7, we have this support available on vSAN. Right. So vSAN file services is also something that we launched in vSphere 7, which was April of this year, which allows applications to now consume vSAN storage using file shares. Now we extended that support to modern applications with the read write many persistent volume integration. And with this, with simply a different access mode, we are now able to consume vSAN file storage using the read write many persistent volumes within the Kubernetes applications. With this integration, we are extending all of the integrated management monitoring capabilities of vSphere to these read write many persistent volumes as well. And as you saw in the previous slide, the storage class to SPBM policies, all of that integration is also available for read write many volumes.
So if I wasn't running vSAN and say was on vVol or some other form, does that mean that I don't have the read write many?
Right. So, so basically, we have the vVol support for block volumes, which is read write ones. So we support read write ones on VMFS, NFS, vVols, and vSAN, but the read write many support is only available for vSAN. Yes.
Okay. Thanks. What is the roadmap? Do you anticipate being able to enable it on vVol attached storage someday, or is this?
Yeah. So. So yeah, I cannot discuss roadmap, but definitely there is interest in it, right? So
Okay.
customers have, so we see interest in this aspect. All right, so this is these are a few screenshots here just to talk about that unified management that we alluded to in the previous slide. What we are showing here is how customers can monitor the capacity that is consumed for both their traditional applications as well as modern applications using a single pane of glass. We show the space that is taken for both the attached as well as detached volumes on vSAN here. Which lets customers plan for their capacity, right, for their modern and traditional applications on the clusters. This is another dashboard that we have introduced. This was introduced as part of 6.7 update 3 itself, including the previous one, capacity monitoring screens. What we're showing here is we show the different persistent volumes across multiple different Kubernetes clusters. We show the block volumes, the file volumes. More importantly, we also show the different application labels that are associated with these persistent volumes, so that developers, if they're seeing any issues, they can talk to their IT teams and have these be troubleshot or monitored using these application labels here. Right, and along the way, we also show the health, capacity, etc. In this particular screen. So this screen is an extension to the previous one. So when you click on the persistent volume, we also show the actual Kubernetes related details here. We show the name of the persistent volume claim, persistent volume, which are the different pods that have these volumes mounted, the namespace associated with this volume. All of that detail is available right within vCenter. And the other tab, the basics tab here also shows the storage related information here. Which is extremely useful for customers, because if you have hundreds of these persistent volumes, and if you're seeing performance or any availability issues with these persistent volumes, it becomes very simple for customers to look at which data store these are deployed on, what is the associated vSphere policy, what's the compliance and health status, what type of volume it is. All of that information is available as part of this tab. Going further, if a data store supports the underlying placement details to be known, we also show the placement of this volume on the storage layer, right? So in this case, we are showing how this particular persistent volume is placed on vSAN, which node, which disk group, which disk has this volume contained, what's the health and capacity of each of these disks. And such details that is relevant to the placement, right? And this is very useful to our customers. In an actual customer quote, one of our customers told us that this shaved off a few weeks from his monitoring and troubleshooting experience for modern applications, right? So this is useful. vSphere with Tanzu support came up in vSphere 7. vSphere with Tanzu is the Kubernetes offering from vSphere. Essentially, the promise here is that it lets customers, developers consume the underlying vSphere resources using native Kubernetes constructs, right? So they are now able to get access to the different vSphere resources directly within Kubernetes without having to actually understand a vSphere, right? And the other important aspect is now Kubernetes applications get the benefit of the underlying hypervisor when it comes to security performance or what have you, and they can get that native hypervisor capabilities that were not possible before Tanzu. That was always extended to these traditional applications, but with Tanzu we are even extending it to the modern applications. So vSphere.
Gopala, I know we have audience members here who are on other distributions of Kubernetes like OpenShift or Pure Upstream. So if maybe you can point out what of what you're showing is available also to them versus the Tanzu distributions, that'd be great.
Sure. So Steven, that's a great point, right? So basically, this slide here, all of the features we talked about, right? That is available for all types of Kubernetes distributions, right? So this is available for vanilla Kubernetes, OpenShift, PKS, Anthos, all of the distributions get the support that we are talking about here. Right, our CSI is an open source CSI driver, and it is available for all the Kubernetes distributions. Now, and in fact, 6.7 update 3, we did not even have Tanzu, and we supported only our ecosystem Kubernetes distributions. Now with Tanzu support, we are also extending those capabilities to Tanzu. With the pod service and the TKG service, we are even extending those distribution support, other distributions that we had support for, to the Tanzu platform here. In fact, we are ahead on the other ecosystem distributions when it comes to CNS support, and we are catching up on the Tanzu side, right? So we are extending the existing support on the vanilla Kubernetes side to Tanzu, right? But yeah, that's a great point, and thank you for bringing that up. So Tanzu offers two types of Kubernetes offerings. The first one is this thing called TKG service, which is going to be compelling for developers who are looking to use conformant Kubernetes distributions, vanilla Kubernetes distributions on the vSphere platform. The use case there is they are developing these applications on either public clouds or other types of Kubernetes distributions, and they want these on-demand Kubernetes clusters deployed for them, similar to the public clouds, but they want that enterprise compliance of the enterprise-grade platform that vSphere Tanzu offers. Right, so that is the TKG service, and the pod service is the Kubernetes that runs on the hypervisor directly, right? And here you get all the hypervisor benefits of performance, efficiency, etc. For applications that are running directly on the hypervisor, right? So this is the other distribution that we offer. We believe that a majority of the applications will land on the TKG service because of the conformant nature of this particular service here. It's also attractive because administrators will be able to hold the control when it comes to policies, when it comes to permissions, quotas, etc. They're still able to get all of that benefit with the TKG service. And we have a concept of a namespace for vSphere with Tanzu, which lets customers and admins allot a particular quota and a policy for that particular namespace, which gets translated into things like storage classes automatically for these namespaces, right? So the key is that the system actually makes sure that you still get all the benefits of the vanilla conformant clusters, but with the vSphere admin control for the workloads. And CNS integrates with this particular Tanzu framework. And like I mentioned, the quota enforcement, the policy enforcement is all done by CNS. And we have the integrated workflows for storage within the Tanzu namespaces, right? And I want to show you a few screenshots of how that looks like. So when an administrator creates a namespace, right, he also has the ability to attach quotas and policies for that particular namespace. And what we're seeing here is you attach the CPU memory limits, the storage quotas, and in fact, quotas per policy, right? So you are able to attach all of that. And we are also able to assign specific storage policies to this particular namespace here. And the storage policies will be automatically translated into storage classes in the underlying namespace. So this is the CNS integration that we have done with Tanzu, and this is a summary view of how this looks like on the Tanzu dashboard. So in 7.0 update 1, we have extended Tanzu to also have some of these features were available on the vanilla Kubernetes like PKS, OpenShift, and Anthos, things like Wols Support. We have made the support available as well on the Tanzu side. So the volume extension is another important aspect that we offered. So we support offline persistent volume extensions, right? And the one other feature support we did was for static provisioning. We are able to now migrate workloads from the other Kubernetes distributions to Tanzu using the static provisioning support that we have in 7.0 update 1. So this is just a vWol integration slide. So vWol support was not there in 7, vSphere 7. We have offered that support in 7.0 update 1. So with this, we believe that external storage is an important aspect for modern applications as well. And we see a lot of requests for external storage deployments. So what vWol integration with Tanzu offers is it offers that capability to bring in vWol policies into the mix here and assign those policies to namespaces, similar to how we have done for vSAN before. And
can I jump in, Gopala? We've got audience members of all flavors here, and I just want to, sometimes these acronyms get out there and they're not sure what they are. So the vVol is a storage interface for vSphere that lets you attach, I don't know what VMware calls third-party storage. Any vendor who wants can write a vVol compliant driver so that you could use, I think, all the popular forms of storage have commissioned one of these drivers. The vSAN implementation is something where you're putting software-defined storage on the vSphere compute nodes themselves. So it starts out with a hardware implementation that is more like direct attached storage and converts it into resilient software-defined storage, whereas the vVol is typically seen in a multi-vendor environment. So correct me if I got that wrong, Gopala, or if you can do a better job, but I just wanted to make sure that this vVol acronym was something everybody understood.
Right. No, I think you captured it very well, Stephen. So vVol stands for vSphere volumes, which is a way in which external storage providers can expose the volumes to vSphere. And the granularity of management is at a volume level, right? So you can assign policies, you can attach these volumes to the virtual machines, and there's a per volume policy that can be assigned, right? So it gives us a very clean way to manage volumes on the external storage arrays. And we have the same concept for vSAN, right? So everything is a vSAN object that translates or maps to the volumes. And the policy is assigned at an object level within vSAN. vSAN stands for virtual SAN, which is the hyper-converged storage offering from VMware. So now we have integrated both vSAN as well as vVols into this mix for modern applications, and that was the storage policy management that I talked about earlier, which now is also extended to the storage classes. So it gives it blends pretty well because Kubernetes is all about volume management, right? All the management happens at the individual volume level. So it lends itself well to the way that we manage volumes on vSAN and vSphere as well, right? So that's the kind of correlation between the two concepts. But yes, thank you, Stephen, for bringing that up. So yeah, so that was primarily what we offered from a platform standpoint, the support in 7.0 and 7.0 update 1. Any questions, thoughts, comments? I want to use the next 10-15 minutes in quickly talking about what we're doing to support object stores, MongoDB, Cassandra, Kafka, such applications. Okay, please feel free to stop me anytime. Again, this is an interactive session. I want it to be discussion based, so please feel free to stop me. So before we talk about the data persistence platform and what we are doing to onboard newer services like object stores, etc., I want to again motivate this by talking a little bit about why we are doing this, right? So the applications that we are seeing in the enterprise is they are changing, right? So what used to be applications that depended on a few database instances, quickly they are transforming into these modern applications that now depend on not just one database instance, but a variety of stateful services, right? So, so when we double click on what these stateful services are, what clearly comes up is object stores becoming one of the main mechanisms in which these modern applications consume storage. Developers would like to have an S3 endpoint given to them using self-service, right? And frequently object stores are almost a default way in which storage is consumed, right? And the other good aspect of object stores is that it lends itself extremely well to different types of applications. So on the one hand, you see high performance analytics, big data type of applications that use object stores, all the way to applications that need cheap and deep dense storage, and they depend on object stores as well. And not to forget the regular application that just uses object store as a storage backend, right? So they to all of these types of applications, object stores have become extremely important, and that's the reason we are seeing it becoming a mainstay in the enterprise. And almost always we also see the other services like Kafka, Mongo, Redis, Cassandra that show up. Primarily because the applications, these newer applications are highly distributed, they're geographically deployed, and they also want their associated data services to be distributed and to scale to multiple geographies like the applications themselves. And all of these databases that we see here fit that bill, and they are also becoming quite popular in the modern application world. So basically, if we ask ourselves the question as to why these are any different, customers have been dealing with databases and stateful applications forever. Some of the things that come up is these are architected differently. These newer services are architected differently. They are the so-called shared nothing applications, right? That manage data availability within their own layer. They don't need the underlying storage layer to provide that replication and availability for them. And they're all highly distributed applications, right? So management is a challenge for customers. And that's another aspect that comes up. And the next aspect is that these are all consumed using the cloud consumption models, right? They're all self-service based. They depend on these Kubernetes CRDs for their consumption. Developers want to create instances on demand. They do not want to open a ticket and wait for an instance to be created for them. So these are all things that come up as differentiators for these newer types of services that we see in the enterprise. And lastly, these are used by a lot of these newer applications. So almost always when we see modern applications, we see these services, right? And this is just a number slide that talks about the number of these applications significantly increasing in the near future. By some accounts, we see that we will have around 500 million applications in the next few years. And the IT spending is more skewed towards the individual application teams, right? And they have a higher say in what type of platform is deployed. So VMware recognizes this trend, and we have both organically and inorganically invested in making the modern application development, Kubernetes application development, easier and seamless on our platform, right? So this is just a slide to talk about what the challenges are. So what we see is developers would like to use their existing knowledge, their toolkits. They would like to use Kubernetes concepts to consume storage, deploy storage, without having to do it in a manual fashion, deploy virtual machines for the services. Right, and the challenges that they face today is that all of this is manual. They have to rely on virtualized instances of these applications and deploy and manage that themselves, right? Which leads to an increased development life cycle. And for administrators, the problem is they're not able to offer that cheaper TCO for operating object stores or any such applications on our platform, right? Primarily because we require the replication to be turned on the storage layer as well as the service layer, even though the services offer availability themselves, right? So that is a concern that comes up all the time. And one other concern that we see is that there is no visibility into these newer services when they are deployed on our platform. So when we look at how an ideal solution would look like, what comes up is we require that self-service for developers, similar to the public clouds. we need a quorum set of services to be available for development, like object stores, Mongo, Cassandra, and a few other services that are critically needed by these application developers. They need that to be available on the vSphere platform as well, and they require that support from the IT teams. On the vSphere admin side, they would like to leverage their existing skill sets to monitor and manage newer applications. And it's all about unified management, right? So utilize your existing clusters to also manage newer services. And when it comes to the platform, we would like to extend all of the existing security performance availability of the vSphere platform to these modern services as well. And last but not the least, the collaboration aspect is very important, because we would want both the admin teams and the DevOps developers to talk the same language when it comes to managing these applications. And we want the system to provide that bridge between the two worlds. So when we look at how we offer these object stores, how we offer Mongo, Cassandra on our platform, we look at a few building blocks for offering this service. So one of the building blocks is Kubernetes, right? And Kubernetes is a very, very important aspect in this whole story here, because like I mentioned earlier in my talk, Kubernetes has solved the management aspect of these modern distributed stateful applications by offering things like operator framework. So Kubernetes operators let the service providers automate a lot of day 0 and day 2 operations, like deployment, lifecycle, scale in, scale out, etc. Even the consumption, right? The CRD-based consumption models, all of that has been solved by Kubernetes. And we want to embrace Kubernetes in taking all of that advantages for our platform. Right, so we are taking the Kubernetes operators from the different independent service vendors for these services. And the other building block is the vSphere with Tanzu platform. So vSphere with Tanzu, like I introduced a little while ago, this gives us that compelling Kubernetes distribution that lets customers integrate these operators on the Tanzu platform, and it offers this pod service, which is giving us the capability to introspect the different operations, like maintenance, like lifecycle for the vSphere nodes. And this is important because we would like to make it seamless for customers to put their host into maintenance mode, upgrade their nodes, and still be aware of the services that are running on top, right? And to provide that such a capability, we need that introspection into the different vSphere operations. And vSphere with Tanzu gives us that capability. Right, and data persistence platform, which we launched, is bringing these two worlds together. We are integrating the Kubernetes operators on the Tanzu framework, but more importantly, this is a key piece of IP that we offer, which is that optimal TCO for services when they run on the platform. The idea here is we are now waiving the requirement to replicate on the storage layer if the service is already offering the data availability in its layer, right? So object stores and all of these other services offer erasure coding and other availability schemes, which are more suited to the application requirement, closer to the application requirement than the cookie cutter availability model that storage layers offer. Right? And we want customers to use those availability models if they so choose to, but not force them to replicate on the underlying storage layer, and provide that optimal storage cost for
so Gopala,
on our service, on our platform. Yeah.
I want to be careful here, because given this is the CNCF user group, that we avoid turning this into a VMware product pitch. If people deployed these scale out applications using standard pure upstream open source tools, there are the standard operators that get bundled with these packages, as well as Helm charts and maybe higher form things like the open source Kube apps. Can you point out what level of visibility that gets delivered here for discovering? Because I think that's the key thing we want to stress here, and not Tanzu specific features.
Sure. I can talk about it, right? So the vSphere with Tanzu, so today you can run any Kubernetes application on Tanzu, right? So that is possible today. So what we are doing here is, again, to be very honest and clear, we do not support the open source on this platform as of 7.0 update 1. So this is only for the enterprise operators. So all of these, so we are announcing partnerships with all of these partners who have a Kubernetes operator. All of these are open source, right? So all of these guys have an open source operator. But they have an enterprise version that is integrated on the platform here, right? And this is specifically the integration with the enterprise operator as of 7.0 update 1.
So can you, the stuff you're talking about, if you're using vanilla Kubernetes with vSphere, you're saying you have to be using Tanzu to do this as well?
So this particular data persistence platform is using Tanzu. Yes. Right. But yes, Stephen, I think you bring up a good point, right? So this is my point in talking about data persistence platform is more to say that, if you have modern applications that are running on any Kubernetes distribution and they have a need for an object store or any other Cassandra Kafka application, we have now provided a way for these modern applications to consume them on vSphere, right? So it was in that context that I wanted to talk about data persistence platform, and not as a product pitch. Honestly, that was not what I had in mind, but what we are doing to offer object stores or other applications to such applications. That was my intent here, right?
So are there plans to also allow this configuration in like just the open source? You talked about even those open source products you talked about, it's their enterprise configuration that's supported. Like where are we looking from the open source side of supporting those features?
Right. So so again, I cannot talk about the roadmap here, but that has definitely come up, right? And the interest in running the operators from the operator hub on vSphere with Tanzu has definitely come up, and we are aware of those asks, right? And unfortunately, I cannot talk about the roadmap, but that is something that we have definitely heard a lot of interest for, right? And if there is, go ahead.
But just to clarify, it's not just vSphere with Tanzu, which is the offering that allows you to get the offering outside of VCF. This specifically requires VCF for the data persistence platform, correct?
Right. So in 7.0 update 1, this requires VCF.
Right. So it's not just vSphere with Tanzu, it's VCF with Tanzu. The whole thing is required.
Actually, just to clarify on that point there, we require, the data persistence platform requires the vSphere with Tanzu pod service, which in turn requires NSX, right? And the reason we are showing VCF here is that VCF brings in all of it together very seamlessly. So it has vSphere with Tanzu, vSAN Enterprise, and NSX that is packaged very well with VCF. But nothing stops anybody from taking these individual components and deploying it and getting pod service, right? So we don't mandatorily require it, but it gives us a good packaging. That's the reason we show it there.
Yeah, at the moment, we do not have NSX anywhere in the environment. So that would be something that we would have to look at first before we could even look at this.
Yeah. So if there is interest, I can definitely schedule a more detailed conversation. Please reach out to me and we can discuss a few more things. But yes, I see what you're saying. Yeah.
This is Robert. From a technical perspective, maybe just a little step back. I'm just wondering what the kind of data management scenarios exist that you're trying to address with this. So you spoke a few slides earlier about data replication scenarios that the cookie cutter model of vSAN might not be ideal for in a modern apps context. I just was wondering if, and this is just to the room, if there are some examples of where this might be the case, because I would like to understand how some of these how this would help in those scenarios. I'm
Well,
familiar
hopefully
enough?
this isn't too simplistic, but as an example, there are some of these, let me call them software-defined stateful services like a Cassandra that already implement some form of redundancy for resiliency up at the software layer. And if you layer those on top of storage that assumed that it also had to implement redundancy, you're sort of paying the cost of dual layers of redundancy, which might be overkill.
Yeah.
So by kind of enabling visibility that this upper layer is already willing to buy off resiliency, redundancy, replication across nodes, you can perhaps send a signal to the underlying storage that, hey, maybe I know your default way of operation is to store things in at least 3 places, but you don't have to for this. Now, Gopala, maybe you can address whether I'm going the right direction there, but I think that's what we're getting at.
Yeah. So so all of these services that we talked about, right? All of these services like Kafka, Cassandra, Mongo, object stores, they all are offering their own availability. There is a reason we call them shade nothing services. And specifically, for instance, erasure coding, right? So customers can turn on different modes of erasure coding that is good for them from a performance and a cost standpoint. They can choose one of the erasure coding methods, and also from how many failures they want to tolerate, right? So it's very prescriptive when it comes to using these different erasure codes. And when they have chosen Minayo or when they have chosen any such service, they want to use their erasure coding, and that's why they go with a particular object store. And what we are doing with this is we are just giving the ability for Minayo to say, hey, look, this is the instance, my instance runs on this particular node, and I want storage to be coming in from that same node, right? That storage compute locality is what we are providing with this platform. And that is it, right? So we do not expect anything else. We just give them that storage compute locality, and those services are now free to go and provision storage as they please, as they see fit, right? And all of the resiliency availability comes from the service and not from the underlying storage.
Okay, so just to double up on my understanding of it, if that's okay, what I would normally do, I mean, we run Minio right now, but we don't have vSAN under it. If I were to have vSAN under our Minio clusters, I would set a storage policy that said, look, you don't need to do erasure coding, you don't need to do mirroring on these volumes, since I know the Minio already has its own model to do this. But what you're saying is that on top of that, this enables extra intelligence to optimize vSAN about the data flow.
Exactly. Okay. Exactly.
Or I think maybe what we're getting at is you don't have to do a manual override or configuration, that it might just happen automatically, that the operator is aware of it and does the right thing. You know, it's not that it wouldn't work if you didn't do double encoding, but maybe you're throwing money away that you don't have to.
There is more to it as well, Robert, in that if you just set a vSAN policy, for example, to FTT0, you turn off replication, but you don't necessarily get compute storage locality. They aren't necessarily on the same hosts, so you end up with uncertain failure domains. Yeah. And another part of this additionally is the operators are actually tied into vSphere operations. So if you put a host in a maintenance mode, it will tell the application this host is going away. There's one copy of data there. Move the data off that particular disk, off that host, do whatever you need to do at the app layer. So there is a much more integrated level of interaction between vSphere and the app in these cases. And while, yes, you might be able to get away with it just doing FTT0 and telling it to turn off the replication, you don't get the locality, which is really critical from like a failure predictability standpoint.
Right, and that's right. So that vSAN SNA mode will now allow all of these benefits, or rather configuration, like Miles mentioned, in a completely automated fashion, right? And I pinged the link to our VMworld talk, wherein we actually show Minayo being deployed on vSAN by turning off the replication, and how we automate a lot of these deployment, management, and lifecycle tasks. Right, so please feel free to watch the recording and send me any questions if you have them. right? And I also want to talk about the vSAN direct configuration, which we announced along with the platform. So in addition to the vSAN,
and just a warning, Gopala, maybe a time limit about 5 minutes.
Yeah, I'll just take 2 minutes for this. So, so vSAN direct configuration alongside vSAN SNA, which is turning off the replication and providing the placement control, also lets now customers directly go and deploy the services to the underlying direct attach hardware, like cheap and deep hard disks or performance SSDs, etc. Right? So the idea here is, like we discussed, when you do not have the need to replicate on the storage layer, you might as well give the services access to the direct attach hardware to get that storage efficiency and TCO that the hardware devices are offering, right? To be clear, this is not a direct RDM access, which is raw device mapping access to these services. We still have this VMFS file system, which is VMware's file system for local devices, VMFSL. So we still have that file system deployed on these devices, but now we extend all of the management benefits, that simplified deployment, cloud consumption models, operations, etc., to these direct attach devices as well. So from a deployment standpoint, now you have a choice of either using vSAN SNA, where you turn off the replication and get the placement control, or vSAN Direct, and you can get that TCO and storage efficiency of the underlying hardware devices. So yeah, so that was the other option that we have introduced here. So yeah, so that brings me almost to the end of my presentation. Like I mentioned, this was a high level, so please feel free to reach out to me. I'll provide my email address for any further discussions.
Okay, can we take a step back and look at it from like a CNCF point of view, looking at 7U1 and say kind of from an open source point of view, what does this bring to Kubernetes specifically without Tanzu?
Right. So Miles, you want to talk about our open source? Just tee it up, but then
I'm not talking necessarily about persistent data persistence. I'm just saying
sure.
vSphere.
So,
yeah. Go ahead, Gopala.
Go ahead, Miles.
Yeah, so with regard to like the pure open source vanilla CSI, we added a lot of stuff in prep for migrations. So VCP to CSI migration was added in there. It's in beta state at the minute. So if you have 1.19 or above and the new version of the CSI driver, then you can try the VCP to CSI volume migration, which will do it both at the platform level as well as the Kubernetes level. So it'll insert the webhook shim that we were talking about in a previous meeting to translate all the calls that would go to VCP and makes them work through CSI, but it'll also take the existing volumes and convert them from standard VMDKs into these first class disks and sort of adopt them into CNS. So that requires some code changes. So that was in 7.0 U1 and the new version of the CSI driver. So that's what we added from a vanilla open source perspective.
So
Okay,
that would apply to people who are using legacy cloud providers and
correct. Yeah, if you
storage
use the
plugins?
VCP, yeah, if you use the VCP, that's your off ramp off the VCP onto the CSI driver while maintaining your existing volumes.
Okay, so that would be, you'd want to be first on 1.19 to, is that beta on 1.19 you said?
Beta 1.19, yeah. It's looking like it's going to track like 1.21 or something like that for stable release.
Okay. So for those, everyone that's out there that's currently using the cloud providers, you kind of need both. I mean, you need to first get your vSphere version updated, and then you can then work to get your Kubernetes version upgraded. And then is there a documented process on that conversion?
Yeah, it's on the CSI GitHub. There's a doc that's in there that's like a work in progress doc, and it gives an example of how you would move the volumes over. You essentially you give them an annotation, and then you kick off a flow, and away it goes, and it does its thing. But yeah, you're right. You would go to 7.0 U1 first. you get your Kubernetes distributions up to 119. Make sure you're on the new CSI driver, and then you can follow the process that's in there.
And was there more discussion about when support for the vSphere cloud provider was going to be completely removed out of Kubernetes?
Yeah, we've been chatting with Google on that as well, and basically they don't want to remove the VCP until such a time that they and we agree that the migration path is indeed stable. It is something that is fully supportable, has no bugs, whatever, you know, the way that we do things in Kubernetes. We don't want to deprecate stuff and not leave anyone stranded. So it looks like currently, if we're tracking stable for 1.21, something like that, it's probably going to be 1.22 if it is indeed stable by 1.21. Essentially, it's going to be like n plus 1 on whenever the migration path goes stable. Does that make sense?
Yeah, I would have thought it'd been like 2.3 instead of 2, like just one version. But
they're pretty keen to get the code out of there.
I'm thinking you're going to end up with maybe people like us that have a lot of things to upgrade to get to that point.
Mm-hmm.
Where that is going to, if we don't get those all upgraded, essentially that's going to stop us from being able to upgrade Kubernetes. And then you kind of end up in a...
Yeah, there's probably still time to voice your opinion, which I realize you're doing now. And on your behalf at a cloud provider meeting, I'll certainly pass that along. It isn't just our decision. There's a cloud provider SIG, and they're kind of doing this as a blanket effort across all the cloud providers, not just the vSphere one. So you might be safe, but I can't guarantee it. I can pass along word. And I think, you know, there's differences of opinion where enterprises tend to face more of these issues, but sometimes some of these thinner organizations can move more quickly. But yeah, it's tough. I think the official rule on Kubernetes is that they do promise to give a deprecation warning of at least a year, but I think they view that they've already given the warning that something's coming.
3 years ago.
Yeah, the problem with that is you didn't necessarily have everything there ready to move forward with that.
Correct.
So it doesn't matter if you really deprecate it if you don't really have that path.
Right.
Yeah, I think Stephen kind of hit it on the head. Walmart scale is completely different than any other one that you'll find in the environment, with all the different things and pieces we have running. That when, and basically going with what Bryson said, I think 2 versions would be better than just one after having a stable path.
I mean, looking at it like this just really came out, doing testing on it, you want to validate it, and then you have to roll it out. And I mean, we're at a different scale than a lot of places, but I mean, it could take you a year to go upgrade that everywhere.
Well, let me make this commitment. Miles and I will be advocates for that position, but we don't have solid control over this. I mean, there are others involved in the decision. So I think that we appreciate the need to allow time for people to migrate, but since it isn't under my direct control, I can't make a promise.
Yeah. Also with that is the fact that currently we do not even have in 7.0 in production yet. We have an instance of it in the lab, and we're still having issues with it and working with the vSphere team. Currently, we were actually told today when U2 is supposed to come out. We're not supposed to give out any dates to anyone else outside the team, but we were given a heads up on that so that we will be ready to go with that, even though we still have 2 PRs open on U1. So hopefully those will be resolved when U2 comes out or close to it. And from the way it sounds, at least one of the PRs will be fixed in U2, but we haven't been told if there's anything that we can just patch a U1 with. So we are working on that side of it, but we're not there. I'm mainly bringing this up in regard with the mention of the time, frame mentioned with the whole moving to 7 in production.
So another question then, if the platform level, say you're on 6.7 U3 today, as an example, as the minimum level required for CSI, if you could do the migration on that, as opposed to having to upgrade to 7.0, 7.0 U1, whatever, would that make your migration any more feasible?
In the store environment, we are running 6.7 U3. So
Okay.
that would be feasible.
But we don't have that running everywhere, Wayne.
Yeah, that's the thing. In the store environment, we do. In the DC environment, in the home office environment, and I'm not sure what they're running in the e-com environment, but in all those other areas, if they're not on it, then it wouldn't be. Because each of the different areas, we have our own teams that are basically dedicated to it. I personally am on the store team.
Okay.
So I can mainly only speak for us. I have a general idea where the home office and the DC teams are, but the e-com, I haven't had much exposure to their group.
So I would say like a hard requirement is 6.7 U3. Because that's when the CNS bits first went into vCenter and ESXi. 6.5 is falling out of support. So I would say that's realistically the minimum you can hope for. So that would be a hard requirement. And while I said, yes, 7.0 U1 is required for the migration path, if it's a hard blocker for you guys to not be able to upgrade to say 7.0 U1 or whatever in the amount of time that you've been given, maybe we should have a chat with Gopala or myself to figure out what we can do about the migration path, backport maybe.
So what's the backport here that we need to be thinking about?
The VCP to CSI migration bits that are in VC.
Right, but I think 6.7 update 3 is one option, right? But we need definitely 6.7 update 3, but we can have the thing backported to 6.7 update 3. Yeah, that has come up, and again, we have been looking into that. So yeah, we are aware of that.
Yeah, I think at this point there's no announced commitment to supporting that, right?
No,
but
that's right.
Walmart isn't the first entity, I believe, that has been indicating that they might have issues like this. So
no, our other ecosystem partners have said it as well. Everyone that builds a distribution too.
Yeah.
So I guess at this point we are a little over time, but we'll keep the community involved on where this is going. But it is, in the interest of giving an early warning for something that's projected at this time to happen sometime next year, we just want to be open and also provide a venue for feedback so that the right thing happens here. But we're hearing what you're saying. We'll be advocates for supporting people on Kubernetes on our platforms, both within VMware product planning and because we have people sitting inside the Kubernetes SIG. So we'll do our best and we'll keep you advised of how it's going. I guess that's the commitment it can make. Does anybody else have any final things or things they want to nominate to carry over into the next meeting? Because we're already a couple minutes over. Okay, I'll take silence as nothing, but as always, on the Slack channel, feel free to do any late ads. Gopala, if you can provide me a link to this deck, I will put it into the agenda notes document so people can have access to it. And with that said, I'll close the meeting. Thanks everybody for attending.
Thank you.